Do you guys have same confusion about this problem, or who has joined recently? So let me repeat this question, right? So this is case what? This is case 2. Case 2 meaning we have to get the subtraction of vectors. So VRM should be VR minus VM, right? So whatever the M direction is given, we have to take the opposite of M direction, right? So this is the idea, the key idea. Whenever you get the rain problem, you draw this velocity and you take the opposite, right? Understood? So the car is moving in this direction, right? So this is V of car, right? And the rain appear to be pouring like this, right? So this is the relative velocity of rain with respect to car, right? Okay.
Yes, sir.
And we have to take what? This direction of velocity, right? Understood?
Yes, sir.
So this direction, right? So this is V. Let's just ignore this negative part because it is showing the direction. It is not the magnitude. Okay. So, and this is the velocity of the ray, right? Okay, any problem? So this is 60, right? And these are the two lines. So if this is 60, this will be what? 60, right? Opposite angles, corresponding angles, right? So this is, if this is 60, this will be what? 30, right? Understood?
Yes, sir.
So this is what this is VR. So we can get the relation between VR and V, right? So tan 30 will be what? P by B. So P is what here? Opposite of this base angle. So this is V. And this is VR, right? Okay, so who has joined? Iram. Hi, Iram. Hello. And why my video is paused? Okay. So let me put this here. Understood. So this will be VR. And what is tan 30? It is 1 by root 3. Right. So this is V and this is VR. Okay. So this goes here, this goes here. So VR is root 3V. Understood. Any problem or any confusion, any doubt up to this point?
No, sir.
Right. Now we will use, we already got this relation, the relation between the velocity of the rain and the relation between the velocity of the car when the angle was appearing to be 60 degrees, right? Now we will use the second condition. Second condition is what? That the rain is seemingly pouring like angle with 45 degrees, right? So this is the effective diagram. So this is the velocity with which the car is moving right now with 45-degree angle. So this is the velocity. And what was the velocity given? So the velocity was this, right? And this is the velocity of rain with respect to the car, right? So again, this part is what? 1 plus beta V. Okay, and this is velocity of the rain. Okay, and this is 45 degrees. Understood this diagram? So the main part is that we have to identify the case and then make the diagrams, corresponding diagrams. Understood?
Yes, sir.
So what will be again tan 45 will be what? P by B. And what is the angle, what is the side which is opposite to 45? So this is 1 plus beta V, right? And this is VR. Okay, tan 45 is 1. So 1 plus beta V by VR, right? VR. Okay, and we know the value of VR, right? So this is root 3V. So 1 equals to 1 plus beta V by root 3V. Okay, so V cancels. So root 3 equals to 1 plus beta. Right, so this goes here, and root 3 is what? 1.732 minus 1 is beta. So beta is what? 0.73. Okay, so whenever you get a rain problem, let's say the rain is pouring like this, and the velocity of the man or any object is like this. So if it is like this, then you calculate with this resultant, right? Understood? You calculate this part. Or if it is going in the what? East, west, north, south. Or so if it is going in this direction. So what should you calculate? What resultant should you calculate? This one, na? Right?
Yes, sir.
So this is the only difference in the rain problem and the river problem. In the river problem, you would directly calculate the resultant like this. Okay, so this is river and this is man. So you directly calculate the resultant. But when you calculate the rain problem, this is rain and this is man. So you don't calculate this part. You calculate the subtraction part. Understood?
Yes, sir.
So we have to keep just these points in mind. The cases. Okay. So any more doubt, any more question? Please
No.
ask, because that makes things clear. So Samira has asked about the doubt. Any other doubt? Any question? All of you. If you guys have any question, please ask. So should I move ahead?
Yes, sir.
Okay, so I was doing what? The uniform circular motion, right? So I was doing the questions for uniform circular motions. So let me ask you one question before I start. So Abhinav, can you hear me? Abhinav, are you there? Yes. Alia, okay. So Abhinav is not there. Heather, Aram.
Yes, sir.
Okay. So Heather, what was the direction of the angular displacement vector? Do you remember? So let me just draw one diagram and you tell me what will be the direction of the angular vector, angular displacement vector. So let's just say I move from here to here. So this is my direction, right? So this is my angular displacement. So what will be the direction of the angular displacement? Will it be this or this? Which one? The cross one or the dot one? So the dot one is pointing outwards and the cross one is going inwards, right?
The outwards one.
So you apply the right hand rule, na?
Yes,
So
sir.
you start from A and then you go to B. So where your thumb is pointing?
Inwards.
Inwards. So it will be the cross one, right?
Yes, sir.
Right. So please ask if you have any doubt, because if you keep that doubt, so that will go on forever. Okay. And that makes me a villain because I wasn't able to make you understand. Okay. So please, if you guys have any doubt, please ask. Okay. Explain it again. Which part, Nimra? Can you write it one more time? The direction of angular displacement. Okay. So, do you know the Maxwell's thumb rule? Maxwell's thumb rule, that this is your palm and you start from one end and you go to the other end. So the whichever end, whichever direction your thumb points out, so that is the direction of whatever you are calculating, right? So for A cross B, so let's say you have a vector A and vector B, right? And you go from here to here, meaning you want to calculate A cross B, right? So you keep your palm in A direction and then you roll it to the B direction. So that is your A cross B direction. So whatever direction your thumb is pointing out, that is your A cross B direction. So that is the Maxwell thumb rule. Okay, so we apply the similar scenario here for angular displacement. We keep our palm in the A direction, okay, and we move to B direction. So whatever direction your thumb points out, so that is the direction of the angular displacement, right? So is it clear now? Sorry. So is there any doubt? Okay, no doubt. So let us just do some question. And if I lag behind syllabus, then I will take some extra classes. Okay, so is that okay with everyone? Because I don't have time to lag behind. Okay. So our time frame is very limited. Okay, if extra classes are okay with you all.
Yes,
Is that
sir.
okay? Okay, thank you.
Yes,
So
sir.
let's just do. Okay, sorry. Sorry. So, who's? Do you have any doubt? Someone was stuck in after Namaya. Okay, so let's just start and let's just do some questions. So equation of angular displacement is given as theta, which is dependent upon time, right? And we have to find the average angular velocity from t equals to 0 to 2 seconds, right? So what was the average displacement, theta average? What was it? Do you guys remember? It was delta theta by delta t, right? Right now, so theta 2 minus theta 1 by t2 minus t1, right? So this was the average velocity. Remember, Arpit? Okay, so let's do the first question. So we have to find t1 is what? T1 is 0 second and t2 is what? 2 second. So let's just find theta 2, right? So theta 2 is what? 3 2 square plus 2 plus 1. So this is what? 16, and theta 1 is what? Right, so this is what? 6. So what will be delta theta? Aram, delta theta will be what? So average will be delta theta by delta t, right? So theta 2 minus theta 1 by t2 minus t1. So theta 2 is what? 16 minus 6 by 2 minus 0, right? So 10 by 2, which means 5. And this we measure in radian, right? So 5 radian. Understood? Radian per second, right? This is, what did I write? Okay. Understood? Sorry. What am I writing? You guys didn't point out the mistake. Okay, so this is the angular velocity omega, right? Understood?
Yes, sir.
Hiram? So you guys should point out the mistakes. Okay. So now let us calculate the angular velocity at t equals to 2 seconds. So this in this second question, they are asking about what velocity, what angular velocity? They want us to calculate what? Instantaneous angular velocity. Right. So what is the instantaneous angular velocity? Heather, what is the instantaneous angular velocity if you can recall yesterday class?
Delta theta by delta t.
So that was the average velocity, right?
D theta.
Yes. So d theta by
D theta by
d.
dt.
Yes. So d theta by dt. Remember, your average angular velocity was so your m average was delta theta by delta t, and instantaneous was d theta by dt, right? So we have to calculate this at an instant at t equals to 2 seconds, right? So omega will be what? D theta will be what? So theta is 3t square. So this is what? 60 plus 2, right? At t equals to what? 2 seconds. So this is what? 14 radian per second. Or we write it as rad per second. Understood? Any doubt? Any doubt up to this point?
No, sir.
Okay, so now the second question. Okay, Arpit, a body complete 5 revolutions. 5 revolutions means how much the angular displacement? Only the magnitude of angular displacement. So a body starts from, let's say, this point, 1 revolution, 2 revolution, 3, 4, 5, right? So what will be the total angular displacement? Right, what will be the angular displacement total? So for 1 revolution, Anna, For one revolution, how much it covers? The angle wise, how much it covers? Angle wise. So
360.
this, yes, 360 means 2 pi, right? So for 5 revolution, it will complete what? 5 into 2 pi, 10 pi radian, right? So this is the angular displacement for 5 revolutions, right? So we have theta is what? 10 pi radian, right? So what will be the angular velocity? In 10 seconds. So t is what? 10 seconds. So your omega is what? 10 pi by 10, which means pi radian per second. Understood? And what will be the linear velocity? Okay, so I didn't give the, so let's say the radius of this track is 2 meters, of radius 2 meters. Okay. So what is the relation between linear velocity and angular velocity? V and omega. So what was the relation? Can you guys recall?
Omega R.
Yes, right. Omega. So d theta by dt. Okay, Arpit. Acha, Arpit. Okay, so sorry, Arpit, I didn't see the chat. And Alia, yes. So V is equals to omega R. And we have omega is pi, radius is 2 meter. So this is 2 pi, right? 2 pi meter per second. Okay, and what about the centripetal acceleration? So AC is what? You can write with respect to the linear velocity or the angular velocity. So it was V square by R, right? So V square is what? 2 pi square by R is 2. So this is what? 4 pi square by 2. So this is 2 pi square, right? So let's just move on to the next question. Okay, please note down this question. Okay. Are you guys listening? So please note down this question, and this is your homework. Send me the PDF of this question. So this is your homework. Please note down. Okay. So everybody taking the screenshot or noted down the question? So the question is that your second and your minute hand and second hand are moving. So after one completion of what second hand, what will be the angle? Is it what? So you guys calculate. Okay. Okay, understood. I am just giving you a hint that the distance or the angular distance. So the difference of the angular distance of hand and second, minute hand and second hand will be what? So theta minute minus theta what second will be 2 pi. So this is your hint. Now use omega relation and try to solve this question. Okay, so this is your hint. Right, so please take it as your homework and send me the PDF. You have got what? 7 days, Saturday, so 6 days, 5 days. Okay, so let's just do the, so let's do the next question. So a particle is moving. A particle is moving along a circular path with a constant speed of 10 meters per second. What is the magnitude of change in velocity of the particle? Okay, so a particle is moving. So this is one velocity v1, and it has completed what? 60-degree angle. Okay, and it has come to this point. So this is now the velocity, right? So v1 and v2 are making what? 60-degree angle. Okay. Now you guys have to calculate what? So v1 and v2 are making what? 120 angle. So this is v2 and this is, so now they are making a 60-degree angle. Okay, 60-degree angle, and v1 is given, v2 is given, and we have to find what? Change in velocity, right? We have to find delta v, which is v2 minus v1. Okay, so this is the subtraction of vectors, right? So this is subtraction of vectors, and can you please recall the formula for subtraction of vectors? So v1 magnitude is what? 10 meter per second, and v2 magnitude is what? 10 meter per second. Theta is what? 60-degree. So can you guys recall the subtraction of vectors and tell me what will be the answer? What was the magnitude for the subtraction of the vectors, Iram?
A square
Yes.
plus b square minus 2ab first.
Yes. Yes, right. So this was the formula for the subtraction of vector. So we just have to put the values. So magnitude is given, the angle is given. So delta V magnitude will be what? 10 square plus 10 square minus of 2, 10, 10 cos 60, right? So this is half, this is half, okay. So 2 cancels. So we have 10 square minus 10 square. So this is what? 10. B, right? Okay, so Arpit has solved. Okay, right. So right answer, Arpit. Thank you. So 10 is the answer, right? Okay. So next question, and then we'll move on to the Newton's laws of motion. So this question is very simple, and it is asked in NEET 2016. Okay. So the acceleration is given in this question. So a body is moving like this. So a body is moving in this direction, right? And it has an acceleration vector. Okay. So this has, so let me draw a nice one. So okay. Okay, so delete this and yes. So root 32.5. Root 32.5, and so okay, so let's just calculate, is it root of 32.5? Okay, So let's just calculate first, Arpit. Okay. So you are very fast in solving this question. So
This I did yesterday.
okay.
And I did the same question yesterday.
Okay. That is the okay. Right. So nice. You are practicing some questions. So the acceleration vector is given, right? And what is the acceleration which points towards the radial vector? Right. So they are asking about the speed of the particle is what? So they are asking about the speed of the particle, v. Okay. And from here, what we can calculate? So this acceleration has two components, right? Option D, 6.2. Okay, so let me see. Is it 6.2 or root 32.5 is what? So this is 5 point something. Okay, so root 36 is what? 6, and root of 25 is 5, right? So in between is what? 5.7. So let's just see that Arpit answer is 5.7 and Sanya answer is what? Okay, I can't see the chart right now. So Sanya answer is D. So we know that the radial acceleration is what? Iram, can you recall what was the radial acceleration, which always point towards the inwards to the radius of this circular motion? The centripetal acceleration, right?
Yes.
Right. So we can find from this part, okay? And this is what? A cos 30 is what? Your centripetal acceleration, right? So your acceleration is given, okay? Acceleration is given and radius is given, right? So you can calculate the centripetal acceleration from this, right? And this centripetal acceleration is related with v, right? And how this is related? So your centripetal acceleration is what? V square by r, right? So you calculate the base component of this, the angle component, or you can say the horizontal, but this is not actually the horizontal one. So you can calculate the radial part, right? So this gives the centripetal acceleration, and from centripetal acceleration you can find the velocity, right? So A cos 30 is what? 15, and cos 30 is what? Root 3 by 2. Okay, and this is equals to what? V square by r is what? 2.5. Okay, so we can calculate the value of v. So this will be what? 15, and then okay, 1.73, and this is 2.5, and this is divided by 2 root overs, right? So this is v. So what will be the value? Let's just calculate the approximate value. So 17 and 15 and 2.5. So let's just, so this is 7.5. Okay, so can you guys tell me what will be the root here? What is this value?
64.8.
64.8. Okay, so 64.8. So that is beyond 6. That is not the answer, right? So what am I missing? Is it 64 point?
64.8 divided by 2. Like I just
Okay. So I told you to just calculate this.
32.4. Okay.
Okay. So this is okay. Now, okay. So 32.4. Right. So this is what root something. So this is nearly 5.7. Right. Oh, am I correct?
Yes, sir.
So C is the answer. Right answer. Sanya, please check your calculation. Okay. So now this chapter is completed. Your motion in 2D is completed. And now we will do this fourth chapter, which is Newton's laws of motion. Right. So as you guys already know about what are Newton's 3 laws of motion? You guys already know. So I don't ponder about that in detail. Okay. I will just write that part and we will do some calculations. Okay. So what were Newton's 3 laws? So first was what? Law of inertia. And you guys already know. So I will skip that. The second one is important one. And what is that? Your force is directly proportional to change in momentum, rate of change of momentum, right? So your force is equals to what? dP by dt, and your momentum is what? Momentum is what? Mass into velocity, right? So your F is what? F is what? M dV by dt plus V dm by dt, right? Right? Right, Anna? Am I correct?
Yes, sir.
So does your mass change with time in a normal scenario? If a
No.
body is moving with some velocity, so does the mass changes?
Oh,
So it remains same for normal scenarios. But for case of, let's say, rocket system, when you propel rocket with fuel and fuel is burning, so the fuel is burning and the mass of fuel is decreasing. So in that case, your mass is not fixed and it is changing. So in that case, this component is there, but in normal scenario, this mass is constant, right? So this is 0. And we already know that what is dV by dt. So this is acceleration. So this is, that is how you get F equals to m. And the direction of force is in the direction of acceleration, right? So this is the second law, and it is also represented like this. So m v minus u by t, right? So F is what? M delta v by t. And when you take this part here, so this is ft, which is what? M delta v, only the change of momentum. So this is called the impulse. Okay. And you guys have already heard of numerous times the Newton's third law, right? So Newton's third law is what? Action, reaction, like. So I don't need to explain this, right? So this is in Newton's laws of motion. The most important law is the second one. Right? This is also important, but we are, for numerical purpose, this one is more important, right? So we will do some calculation based on this part one. Okay. So do you guys have any doubt? Any question?
sir, can you explain what is impulse?
Impulse, yes. So when your momentum is changing, right? So let's say you catch a ball. So you are playing a cricket, and you are catching a ball. Ball is coming with some speed. So you change the impact of the force, right? So the momentum is changing. So the change of that momentum is called the impulse, right?
Yes, sir.
So simply it is it is change of momentum without the rate. So if you have rate of change of momentum, that is force. But if you only have the momentum change in momentum, so that is called the impulse, right? So that is how to decrease the impulse, the impact. You increase the impact time, right? So your force is decreased. That is why you increase the impact time when you are catching a ball. Understood? Understood, Arpit?
Yes, sir.
Okay. So now let's do some questions based on this. Okay. So this one. A ball of mass 0.15 kg is dropped from a height 10 meter, strikes the ground and rebounds the same height. The magnitude of impulse imparted to the ball, right? So as we have discussed earlier, what is impulse? So impulse is
delta V.
simply, yes. So M delta V, right? So we have to calculate, and delta V is what? V2 minus V1, right? So the ball is dropped. The ball is dropped, and then from here it bounces back and goes here, right? So the magnitude of impulse imparted to the ball. So here the momentum is changing, right? So we will calculate the impulse from here, right? So here your V2 is what? In the negative direction. And here your V1 is what? Your V2 is what? V1 is in the negative direction, and V2 is in the opposite, the positive direction, right? So V2 is what? But mass is what? 0.1 kg, and your height is what? 10 meters, right? So can you guys recall the free fall question? So if it is moving like this, and nearly when it was about to strike the ground, so what will be the speed? Your initial speed is what? 0, right? So your initial speed is 0, and it is dropping with some with the acceleration g, right? So what will be the magnitude of final velocity? So u plus 80, we don't want to calculate the time. So the third equation, right? So which equation we will use? The third equation, right?
Yes, sir.
So this is 0. So V is what? 2gh, right? And what will be the direction? It is in the negative of j, right? So V, let's say this is negative of j, right? Understood? This is V1. And what about the V2 velocity? So V2 velocity will be what? Again 2gh with the plus sign, right? Plus j. Understood? So what will be the delta V? This will be 2gh minus of minus 2gh, right? So this is what? 2 root 2 gh, j hat. So magnitude will be what? And g is what? 10. H is what? Answer B, right? So 4.2. So let's just calculate the answer. Okay, why did I? Okay, so let's just first calculate the answer. So 10 meter and 0 h is what? 10 meter. So this is what? 2, 10 is outside, and this is what? 2. So 20 and root 2 is what? 1.41. Right. So this is what? 28. Oh, let's just keep it like this. So 20 into 1.41. So what will be the impulse? Impulse will be what? Mass is 0.15 and 20 into 1.41. Right. So this goes here. B. So Arpit and Heather have got the same answer, so that should be correct, right? So let's say this is what? No. So what? Let's just say both have the same answer, so this is the correct one. Okay. Or you calculate this part. So what will be this? So this is what? 0.15 into what? 28 and what? 182, right? And 28.2. Okay. So into 15 divided by 100. So this goes here, and 3 and 4. So 7. Okay, why am I getting a different answer? So let's just calculate again. So did I do something wrong in calculation? So 2GH, so 2 into G is 10, so 10 is outside, so 20 into 1.41, right? So this is the change in velocity. And multiplied it with what? So 15 into 20 is what?
Sir, it is
Okay.
4.2 only.
Okay, so this is 4.2.
Exactly, it is
Okay.
4.23. So
Okay, so right. So 15 into 2 is 3. 300, and then 3, and 14 into 3 is what? So 42.3, right? So this is the correct answer, right? Now let's just do this second question. Okay. Or take it as your homework. No, let me. Okay, so Anna, Sanya, Idam, Namira, any question? Any doubt?
Yes. Yes.
Okay. So let's just do this question, and then I will take this as your homework. Okay. I will give you a hint. So yes, so homework. So take it as your homework. Nimra, take it as your homework. So I will give you the hint. An explosion breaks a rock into 3 parts in a horizontal plane. 2 of them go off at right angles to each other. The first part of mass 1 kg moves with a speed of 12 meters per second. And the second part part of mass 2 kg moves with 8 meters per second speed. If the third part flies off with 4 meters per second speed, then its mass is, right? So we have to find. But before that, let me give you one more concept that I missed, right? And that was what? So I missed. Yes, so before doing this question, keep in mind that the important law. So there are 2 important laws in a moving body, right? So one is what? One is obviously the law of conservation of energy, right? And the second part that will be useful here will be law of conservation of linear momentum, right? So this part says that your final energy is always equals to initial energy. So in your mechanical energy part, you have already in free fall, you have already came with this point that your potential energy initial plus kinetic energy initial was equal to what? Potential energy final plus kinetic energy final. So in your free fall, you already got this point, right? You should have came across this point. So this was about the law of conservation of energy, right? And what is law of conservation of linear momentum? So in a collision, so when two body moving with v1 velocity, so this one is m1 and this is what, m2, which is going in this direction. So let's move it in this direction, right? So this is going like this with v2 velocity. So when they collide, right, and after the collision they move like this, okay, and they move like this, right? So this is m1 and this is m2, right? So the momentum before the collision, so the p initial will be equals to p final. So this is called the conservation of linear momentum, right? And in vector form, this will be what? So this is in the vector form. Understood? So we have to use this this analogy. So this law or this idea, right? Understood? Any question? Any doubt? Heather, Arpit?
No, sir.
No, sir.
Okay. So let me rub this part and give you the idea of this question. So let me rub this portion. So the idea is that an explosion breaks breaks a rock into three parts. So before the explosion, so what was the momentum of the rock? Momentum of the rock before the collision, before the explosion. So Anna, what was the momentum of the rock before the explosion? Was it moving or what? Does it had velocity? Iram, does the rock had any velocity before the explosion?
No, sir.
So the momentum would be what?
0.
Right. So momentum will be 0 because mv, velocity is 0, means your momentum is 0, right? So the initial momentum is 0, right? And about the final momentum, so this mass the first part of mass 1 kg moves with a speed of 12 meter per second. So one mass moves with 12 meter per second, right? And it has a mass 1 kg. So what will be the momentum? So mass is 1 kg. And velocity is what? 12 meter per second. So what will be the momentum? Let's say P1. So 12 into 1, 12, right? And in this direction, so let's say I hat. So 12 I hat. Okay. And the other one of mass moved 2 kg moves with 8 meter per second speed, right? If the third part flies off with 4 meters per 4 meter per second speed, then its mass is, right? So two of them goes off at right angles to each other. So this one and this one goes at right angles, and this, the third one, goes with some angles. So this is P2, right? So P2 will be what? Mass is what? Mass is 2 kg. And velocity is 8 meter per second. So what will be the velocity P2? Iram, what will be the momentum P2? Iram, what will be the momentum? Arpit, what will be the momentum P2? Heather.
Yes, sir.
So what will be the momentum P2? Mass is 2 and velocity is 8, right? So what will be the momentum?
Velocity is 8.
Yes, velocity is 8 and mass is 2. So what will be the momentum?
16.
Yes, 16. So this is simple, right? Why are you guys not responding? So this is 16. And what will be the direction? So this is going like this, right? So the direction will be what? J hat, right? So your P in 0, P final would be what? P1 plus P2 plus P3. We don't know about P3, right? We know about P1, which is what? 12I plus this is what? 16J, and this is P3. And this is 0. So the hint is that you calculate P3 and calculate its magnitude, and then calculate, you have the velocity given. So velocity is given, so from that you calculate the mass, right? So this is your hint. I have completed the 50% of this question. So rest you do. Okay, any doubt? I guess no doubt. Okay. So I am rubbing this, so please take the screenshot if you want. So am I not clear to everybody? Why isn't everybody responding? Do you guys have any problems or any question, any query, please? Is this getting confusing or boring? If I had time, then I have made some jokes, but unfortunately, I don't have much time. I have a very few time to complete this syllabus, right?
Yes,
So
sir.
we can't joke,
Yes,
we
sir.
can't. That is why I'm very focusing on this syllabus. So if you guys won't respond, then that would make problems, right? Then I would not be able to understand that if you guys are understanding or you guys have some doubts. Okay, so please respond. Yes. So the next question. A body under the action of force, so force is given, right? And acquires an acceleration. So acceleration is given. Right, not the question part. The mass of this body must be. So this is a very simple question. Your force is given, your acceleration is given, and you have to calculate the mass, right? So this is simple one. Now tell me the answer, you guys, in the chat box, or you can unmute yourself and please tell me the answer. You guys calculate. From now on, I will do some question. You will do some question and I will listen. Okay. So this is a simple question, right? Your force is given and acceleration is given. And you have to calculate the mass. So just calculate the magnitude of F and A and use this formula. D. Okay. So anybody else got D?
Say root 200.
Root 200, right? So root 200 is what?
Yeah, say D only.
100 into 2, right? So 10 root 2, right? So D, so 2 people. Yes, so Sanya has got, so 3, so majority, right? Alia has also got 2 root 200. So yes, so now you guys are responding. So that is cool. That is, yes, so one more person. D, Anna, right, Anna. Thank you for responding. Okay, now let's just do the other question. So the initial mass, yes, so this problem, okay. Rocket and what? Rocket and propeller problem. Okay. So as I have told you earlier, that in rocket system, you have to use the second part also, right? So your F was what? dP by dt, right? So in this rocket calculation or rocket propeller question, you use the relative velocity scenario, right? So the idea is that we use relative velocity. Okay, so your rocket is going like this and propeller is moving like this, right? So the fuel is pushing this way and the gravity is pushing this way, right? So you have to calculate the relative velocity, right? So this relative velocity doesn't change. This doesn't change with time, right? So this is what? dt and m and this v relative, right? So this will be what? V relative dm by dt plus what? M dv relative by dt, right? So this part is constant for a rocket propeller system because your relative speed is, you are calculating the relative speed. So let's say your rocket is moving with what? 300,000 meter per second and its propeller is moving like this. So 200 meter per second, right? The gas comes out with this speed, right? So the total will be what? The relative will be what? This minus this. So this will be what? 800 meter per second, right? So that is why you calculate the relative velocity. Okay. Oh, so if this is going this way and the gas is going this way, so this will be 1200. So 100 or 1000 minus of 200. So this is 1200, right? So 200 meter per second relative velocity. Okay. So in this rocket system, you calculate the relative velocity, and this doesn't change with time. So this is 0. So your force for your rocket system will be what? V relative into dm by dt, right? And you know that your mass is decreasing or increasing. What?
We're decreasing.
So this will be a negative sign, right? So that is why you have a negative sign. So this is a key idea for a rocket system, right? So now we will use this idea, and the other idea is that I wanted to teach you the free body diagram earlier, but I will do that in friction part. Okay, when I start friction, then I will do some free body diagram. So let's just bear with me and just take it as granted that the free body diagram of the rocket and the gas system, right? So this mass is what? This mass is the mass of gas, right? So the gas is burning, so mass is depleting. So this is the rate of change of mass. So calculate the rate the fuel should be burned. So this is the fuel, the rate of fuel burning, right? So please remember this formula. For a rocket system, rocket fuel system, we use this formula. We don't use this formula, right? For rocket system, we don't use this formula. And one more thing before I solve this question is that let's say you guys are familiar with free body diagrams? Are you guys familiar with the free body diagram?
Which the area vector and the gravitation, like this, there are arrows where the force.
Not that one. So the free body diagram is free body diagram is about the contribution of all the forces. Right. So let's just say that your mass is kept on the surface, right? So this mass has one force which is pulling it downwards.
Gravitation.
So this is mg, and one other force which is acting perpendicular. So this normal reaction, this is called the normal reaction, right? And in the friction classes, you will learn about that one force is also acting, which is the static friction. But this we will learn in the friction part. Okay. So free body diagram is about the contribution of each and every forces that is acting on a single body. Let's just say that you have a pulley, right? You have a pulley, and one mass is hanging from this pulley, right? And one mass is, so this is a pulley, and one mass is kept. So one mass is attached with a string. Okay. So one mass is attached with string, and string is hanging with this pulley, right? So there are two bodies. one is this and the other one is this. And if this one is heavier, let's say this is 10 kilos and this is 5 kg, right? So this will move this way and this will move this way, right? So this will pull this one. Understood?
Yes, sir.
So we will dissect this into two free body diagram. So one free body diagram for this one, this 5 kg one. Okay. And one free body diagram for this one. So 10 kg one. And we will calculate from the free body diagram, we will calculate all the forces acting on this body, right? So for this 10 kg one, this is connected with a string. So there will be a tension, right? So for string, you have a tension which acts against the motion of the body, right? And there is what? There is a weight, right? And what is another force?
Normal reaction.
When you have a string attached, so that acts like a normal reaction, right? So that the string is attached with this mass, so the tension will act like a normal reaction, right? Understood?
Okay, sir. Yes, sir.
If there were no string attached, then there would be a normal reaction, right? So one is what? This tension. The other is what? This weight. And the other is what? This is moving like this, right? Right, na?
Yes, sir.
So there will be a force ma, accelerating force, right? And what is the Newton's second law? That summation of all the forces will be ma, right? So in the free body diagram, whatever is in the direction of this acceleration, we take it as a positive, right? So what is in the direction of this acceleration? Let me make this diagram here, right? So one is weight mg, one is acceleration, and one is tension, right? So what is in the direction of this acceleration? Heather, what force is in the direction of this acceleration? Force, na? Weight, na? Right. Iram, did you understand this part? Iram? Anna? Any doubt?
Understood, sir.
Yes. So weight is in the direction of this force, in this acceleration, right? And tension is opposite to this acceleration. So we write mg minus t equals to ma. So this is the free body diagram concept of this block, right? Understood this part? Understood?
Yes, sir.
And for this block, which is kept like this, so I should have, so there will be friction, there will be acceleration, there will be normal reaction, and there will be mg. Okay, so not this question. Let me. Okay, so I didn't tell you about the friction. So let's just accept that there is a friction will be acting. There will be a friction. So when I do the friction part, then there'll be more, this will be more clear. Okay. So for the 5 kg block, so for a 5 kg block, you have an acceleration, right? And you have a tension also. So this is attached with, and this is moving like this. So there is a tension in this direction, right? So tension in this direction, there is a normal reaction, there is a friction, and there is a weight. So all these, and your normal reaction is what it is making in equilibrium with what? This weight. So this is canceling out this weight, normal reaction. So that is why you have only this horizontal kind of velocity, horizontal acceleration. Understood? So I think that I'm making you more confusing. I'm making this more confusing right now. But just let's bear that when we complete the friction and the pseudo force part, then this would become more clear, right? Understood?
Yes, sir.
Yes, sir.
So just remember that free body diagram is about what? So let me write two important things about the free body diagram, and then I will solve that question. So let me write two important things about free body diagram. Okay, so main points of free body diagram. It is called FBD diagrams, right? So it is about the contribution of all the forces acting simultaneously on the object, on the body, right? And the second point is that we take those forces positive which are in the direction of acceleration, right? And we take negative for vice versa, right? For otherwise, not vice versa. Understood? So please keep in mind these 2 points, right? So now let's just solve this question. Okay. So this is the rocket. Okay. And gas is pulling out like this. And the relative velocity of the rocket is what? 500 meter per second. So this is 500 meter per second, right? And the acceleration of the rocket is what? So the acceleration is this, right? And the mass of the rocket initial mass of the rocket is given. So this is mass is given, which is 1000 kg. Right. The gases with respect to the rocket, we have to use G. Right. So what we have to calculate is what? We have to calculate the rate of fuel burned. Right. So we have to calculate what? dm by dt we have to calculate. Right. Understood this part?
Yes, sir.
Now, the idea is that we have to use the free body diagram. So what are the forces acting on this rocket? So what are the forces acting on this rocket? So one force is that the burning of fuel is creating an upward force, which is called the force of thrust. Right. So one force is thrust force. Right. Which is equals to what? We have calculated V relative dm by dt. Right. And what are the other forces? Iram, what is the second one? Second one is the gravitational force. And the third one is this acceleration. Right. So this is the free body diagram. Okay. And from Newton's second law, which is like summation of F is M. Right. That all the forces should be M into A. Right. Understood? So what will be positive and what will be negative? So this is F thrust and this is mg, which is equals to ma. So mg will be positive or negative?
Negative.
Yes, and negative, and this is positive, right? So we know that F thrust is what? V relative dm by dt we have to calculate, minus m is what? M is what? 1000 kg. And g is what? 10 meter per second square. This is 1000 and this is what? 20 meter per second. So dm by dt v relative is what? 20 into 10,000 plus 10 into 10,000. 10 into 1000. So this is what? 30,000. Right? V relative dm by dt. So dm by dt will be what? Thirty divided by V relative is what? 500 meter per second. So 6 kg per second. Right. So 60, right? 60 kg per second. So this one. Understood?
Yes, sir.
Okay. So take this as your homework. Right. And I am getting very low of time. So okay. So this one is also your homework. This one and this one. So how many homeworks? 4, right? 4 questions, right?
Yes, sir.
So you have 5 days and 4 questions. Please do that. Okay.
Okay, sir.
Now, the next topic is what? Friction. So, what is friction? So, it is the force which opposes the motion of the body. Right. So, this is the friction. And there are 3 laws of friction. One is that it is dependent upon the normal reaction, right? The normal reaction. The second one is that it is independent of area of contact, right? And thirdly, it is dependent upon the roughness.
Your area of contact will be more, then friction will be more.
No, it is independent of area of contact, right? So if you have a smooth surface, right? So if you have a smooth surface, let's just say that you have a tiles and you place another tile on that surface. So that doesn't change the force of friction, right?
Okay, sir.
So it only depends upon the roughness of this material. So if you have a rough surface, then your friction will be more. If you have a smooth surface, then your friction will be less, right? It doesn't depend upon the area of contact. Understood?
Yes,
So
sir.
these are 2 different things, the roughness and the area of contact. Okay. So, so there are 2 kinds of friction. Okay, so I've already out of my time. And so the next class will be what? In Saturday. So I will try to wrap up this friction and pseudo force and the dynamics of circular motion in the next class. So please come up with the doubts in the next class, and I will for the first 10 minutes I will take the doubts. Okay. And I will talk about free body diagrams in that first, because I guess that I have made a mess of free body diagrams. So I will talk more about free body diagrams in the next class. Okay.
Okay.
Is that okay with everyone?
Okay, sir.
So let's meet at Saturday and then we will move on from there. Bye, everyone.
Excuse.
Thank you, sir.
So Heather, did you say anything?
Yes, sir. Sir, actually, I was not able to attend yesterday's class properly because right
Okay.
before class, I had met with an accident, so I was not.
Oh, are you all right? Is everything so?
Yes, sir. Now I'm better, but just that my right hand is not like there is a muscle.
Okay. Okay, so there is some muscle problem. Oh, so
That's why I was not able to respond and all
okay,
yesterday.
no worries, no worries. So your health is more important than the class. Okay, so we will take extra. We can take extra classes and talk about that in that class. Also, no worries.
Okay, thank you, sir.
So okay, so we will. I will talk with you, and whenever you are free, and I am free, then we'll take that class. Okay.
Thank you, sir. Sir, because there is less time, so I can just watch the recordings, and if I could get the one note.
Any doubt? So yes, so you watch the recordings, and if you have any doubt, then we'll discuss that doubt in this class. Okay.
Sure, sir. Thank you, sir.
Okay.
And can I get access to the OneNote that you used to teach us for the notes, because in class there is less time to write.
Okay. Okay. Acha. Oh. So